Okay, so I am recording the study guide so that if you want to hear it again from what we've gone over in class or just to review for yourself before you take the test. So, suppose a friend sells wrapping paper for a fundraiser. The more paper sold means more money raised. So this is a little bit different than what we've had in the past because I told you exactly what was a function of what else, but we're going to figure it out this time. First off, you're supposed to define the variables for the two items. So remember, a variable is a letter that represents a number. I've given you the variable in the past, but you got to think about which two things are changing. So hopefully you can see that one of them is wrapping paper. So whether you want to use W or P doesn't matter. I'll use W. W, and that stands for the number of rolls of wrapping paper. It's usually sold in rolls. Number of rolls of wrapping paper. Okay? And then the other variable, the more paper sold means the more money is raised. And money we often count in dollars, so we're going to use D for dollars. So both of those letters represent numbers. Number of rolls of wrapping paper, the number of dollars that we have. So now you've got to figure out the function notation. Does W depend on D or does D depend on W? So if does the paper depend on the money or does the amount of money raised depend on the paper? So hopefully you answer that and realize that the money, which is the dollars, depends on the wrapping paper. And we've talked about that means this one is our dependent variable and W is our independent variable. Okay? You will also have a literal equation to solve, save, thinking about wrapping paper. So we're solving for big R. So we're going to undo that operation of multiplication with pi and s, and we're going to divide both sides by pi s, and that cancels. And realize again that this s and those s aren't the same because that's a capital S, that's a lowercase s. So s over pi times little s equals big R plus R. And if I'm solving for big R, then that means got to get rid of whatever else is over there. So we subtract. Remember, you got to show me these steps to get full credit for this problem. So that gives me big S over pi times little s minus little r equals big R. And if you flip those two, that's fine. It's not a problem. Okay, write the solution for the inequality in interval notation. So if you forget what is interval notation, look down here. There's an example right there and right there. So interval notation, we talked about, uh, this has an arrow pointing to the left. So farthest to the left we can go is negative infinity. And where is this dot? This dot is halfway between 4 and 6, which is 5. So we're going to take those two numbers and put them up there. With an infinity symbol, we always have parentheses. And this dot is colored in, so that means it's equal to 5, which means we have a bracket. Okay, again, same thing. What is that number halfway between negative 6 and negative 4? It's negative 5, and that goes to 2. So those are the two numbers that I'm writing on my line. They both equal the number, so they're both brackets. All right, and this time we're going the other way. So we are saying graph the inequality for the interval. So if I do that, um, pick a point on here, negative 8, put a circle. It's a bracket, which means that you color it in. 7, 6, 5, negative 4, put a circle. It's a parenthesis, so I don't color it in, and I'm going to go in between. And I like to squiggle because it makes it easier for me to see. If you want to keep going, negative 3, negative 2, negative 1, 0. Okay? And on the other side, okay, this again tells you the order. So wherever you decide negative 3 is, you put it here. You put a hole in it. Parentheses means I don't color it in. But infinity is over here. So that means I'm shading this way. And please remember to put an arrow so that I know that you know it goes on forever and ever. Okay? All right, this last one, I talked to everybody about it, but hopefully it'll help to even listen to it again. All right, so what it first asked for, f of x equals positive x. When is f of x positive? So remember that f of x, okay, is the same thing as y. And if I want to know where y is positive, most of y'all know, I got to find on that y-axis where my 0 is. So come to your line. I want to make this a skinny line. Let's do this and this. Let's see if I can make it skinny so it doesn't get in the way. Okay, so there's 0. Okay, now we know that this is y equals 0, and this is where it's positive, and this is where it's negative, and that's where it's changing from positive to negative, because anything above up here is positive, anything below is negative. So you got to know where these points are. And I think it easiest to come down with this one because everybody knew that was -3. Then when we came down here, I'm just going to keep going so we get out of the way. That's -3.5. And this one, of course, comes to -2. So on what interval is it positive? Well, it's positive. It goes on forever and ever here. So that's negative infinity all the way to this point. Negative infinity. Okay, and that's the other thing that I had to remind people. Notice that this is the answer is on what interval of x. So when you find the point that it goes to, you got to give me the x value. I don't want the y value. So negative infinity all the way to -3.5 and the u or the or. Then it picks back up at -2 all the way to going on forever and ever, positive infinity. So that's the answer to the first one. Now, where is it increasing? Again, y'all are really good at this, and you can look at this graph and tell me that it starts increasing down here and increases all the way to here. So you look at that starting point, but you don't give me the whole point. You only give me the x values. That's why it says on what intervals of x. So that x value is -3, and this x value is 0. So between those two red dots, f of x is increasing. Excuse me. Okay, let's go to on what intervals is f of x negative? Okay, so we had the intervals here. This is where it changed from positive to negative. I don't want you to lose those. So that means if this is positive, then that means this right here is the negative. So I'm using those same numbers that I used up here. -3.5 to -2. Don't count on these being in the same order or on the test. So you need to make sure that you read them carefully. Okay, um, let's go with constant. I think everybody knows this is where it starts. It goes on for ever and ever. Let's go over here to negative infinity. It's constant all the way to right here. So that's a constant. And here's where another constant starts and goes all the way over here. So there's two places where it's constant, which means I should have two intervals over here. So the pink one is referring. So constant is going to go from negative infinity to, what is this point? The x value of that point is -4. Doesn't matter what the y is. Okay? And the other value, it starts at 0 and continues that way all the way to infinity. So these are my intervals. Okay? And this last one, you want to know where f of x is decreasing. Again, y'all are really good at that. So this is where it starts decreasing from here all the way down to there. Okay? And again, what is that x value of that point? That x value of that point is -4. And the y value, no, excuse me, x value of that point is -4. X value of this point is -3. So that is the interval that it's decreasing. Okay, next page. We have, without graphing the following lines, give the slope and line and name a point on the line. So when you're given these problems, look down here, okay? I will, you'll have the equation right here, but you yourself need to remember M is telling you the slope and the point is HK. And we know that H always goes with the X and K is going with the Y. This is inside your parentheses, so when you write it, it's the opposite of what it looks like. This is outside the parentheses, so it's the same thing. So back up here, the slope is -5, and the point, well, there's nothing with that X, so nothing in math is the number 0, and then there's 14. Okay, and the next one we have -8, and my point, that's inside, so I take the opposite of what it looks like. That's outside, so I take the same thing. And there's my point. So hopefully y'all won't do any calculations when you have to do that one. Okay, so number 10, let's go with write an equation of a line. So we talked about, again, infinite points on a line, so there are infinite points you could use for h and k. But to show me your work, just go find those points that go through the corners of your boxes. There's one, and there's one, and there's one. So there's lots of different ones. You'll need two of them put together. Can't draw very well here. To get your slope. So this is a rise of 4 and a run of 1. So that slope is 4 over 1, or we just write it as 4. But find a point. So if I pick this point, it is at -4, 7. So those are the coordinates, which means my answer would be y equals 4 is my slope, x minus -4 plus 7. Now, if the person next to you said, I want to use this point, the coordinates of that point are -5, 3, okay, then y equals 4, because the slope is the same, but the point is different, x minus -5 plus 3. Both of those answers are correct. So if we want to go one step further and then I'll stop, I think you'll get it. This point, -6, -1. So you want to write that point on your graph so I know that you know how to go from here to here. So this one, y equals 4 times x minus -6 and then -1 because the outside stays the same as what we see. So just know there are lots of different answers and they can all be right as long as you give me a point that your line contains and the slope. Okay, let's go to number 11 and writing our transforming of functions. Okay, so we had this first one. Write the equation of the function y equals x cubed after it is flipped over the x-axis. Okay, so flipped over the x is this way. That means it's affecting my y. Okay, and that means it's going to go on the outside, and we're going to have a negative sign. Hopefully y'all remember that. Translated down 4 units. Okay, again, that's the y, and to the right is the x. So when I write it, negative on the outside, do I have something on the inside? I do. I have that 3. So that's x. And to the right means it's going to be x minus 3 quantity cubed. And then down is -4. So that's your equation. Let's look at y equals the square root of x. Has a vertical stretch factor of 6. So vertical stretch, that means it's applying to the y. So I hope you remember that that is going to be outside, okay? And then 5 units to the left refers to my x. So I'm going to have y equals 6 times, because a vertical stretch is multiplying. This is inside, x minus 5 would be to the right, so x plus 5 is to the left because it does the opposite of what you think. Okay, let's look at number 13. We have y equals the absolute value of x. Vertical, vertically compressed by a factor of 2/3. So again, that's still your y factor. You're going to multiply by that number. You're flipped over the x-axis. We just did that up here, so that's a negative on the outside. And then it's shifted down. Again, that applies to the y. So we don't have anything on the inside because the three things were all affecting the y. So that means I have y equals negative absolute value of x. I forgot my 2/3 in front of that, so let's start that. Y equals negative 2/3 absolute value of x minus 3. Okay, so graph the parent function. That one's going to be in color, and then we're going to do our flipping and give domain and range and symmetry. So for this one, you want to identify the parent function. Remember, that's when we remove the numbers, not the exponents, but any other numbers or negative signs that have been added to it. So our parent function here is y equals x squared. So we got our general shape looking like this. Y equals x squared. And this is inside, it affects the x. This is outside, it affects the y. So we're going to go 3 units to the right and up 1 when I graph my new one. So let's go here. So 3 units to the right, 1, 2, 3, up 1. It's an estimate, okay? And then you've got the same general shape. So it's looking like that. And that's the one we're answering questions about, okay? So what is the domain? Do you recognize that shape? Okay, it's negative infinity to positive infinity. And you'll have your sheet with you, okay? But it didn't change. I mean, moving that left and right doesn't change because I go from negative infinity to infinity. My range, on the other hand, used to start at 0, but it got shifted up 1. So now it's not 0 to infinity, but 1 to infinity. Okay, negative sign. I got to flip it. This is with the x, so that means I'm flipping it over the y. So flipping this 1, 2, 3. If I take this point and I flip it over the y, it's going to go 1, 2, 3 here. So that was the old point. We don't really need that, but I'm just trying to help you. So boom. There, I flipped it over the y-axis. Okay. Are these two the same? They're not. Okay. If they were the same, then we would have an even function. So it's not an even function. Okay, this one is on the outside, so it affects the y, which means we flip it over the x. So I go to that same point, 1, 2, 3, 1, and I started up here, but now I'm going to flip it over the x-axis here, which is going to flip my whole graph. And try not to miss your dot there. Make it bigger so it fits. Okay, so if these two were the same, then we would have an odd function. These two are not the same. Those two are not the same. So the answer here is neither. All right. Next page, we got some more of these to graph. All right. F of negative x. So again, what is your parent function? Hopefully y'all recognize that. It's on your paper. Y equals the square root of x. Okay. It specifically starts at 0, 0. Okay. Make sure you fill up that graph. Don't just stop it right here. Okay. So it's looking like that. My negative is on the outside, so what is it going to do to my function? If it's on the outside, it's going to affect the y. If it affects the y, I flip it over the x. So that means that my new graph is actually going to look like this. They do share that point. So it looks like that. Okay, what is my domain? It's on your sheet. It goes from 0 to positive infinity. It didn't change because I didn't move it left and right. My range changed because now instead of doing this, I'm doing that. So it's multiplied by -1, but you have to write it in the correct order. So it looks like this now. Alright, so again, negative x affects the x. We flip it over the y. So if I flip this over the y, it's going to go like this. Okay, are those two the same? No, they're not, so it's not even. Okay, this one is going to affect the y, so I'm going to flip it over the x. So this is going to become this. Okay, starting there again. Are these two the same? And they're not, so once again we have neither. Alright, moving on. Let's go to f of x equals absolute value of x minus 5. Again, parent function, y equals the absolute value of x. Okay, and I have straight edges. I have lines, not curves, so we can use our, you can use your straight edge that you have on your desk. And let's go draw our absolute value function, which is going to look like this. Quite nice, a blue. Okay, and that 5 is outside, so it affects the y, and I do the same thing, so I'm going to subtract 5. So it's going to go down 1, 2, 3, 4, 5 units. And once you go down those 5 units, again, use your straight edge and draw that same shape, because we talked about how that shape doesn't change. So he's going to go like this. Okay, oops, I didn't mean to do that to y'all. Okay, so let's do the domain. Did I shift this thing left or right? It doesn't matter because it's negative infinity to positive infinity. Oops, have to get the pen. So we go negative infinity to positive infinity. The range used to be from 0 to infinity, but I moved it down 5 units. So now, not 0, but negative 5 to infinity. Okay? Negative is inside. Inside affects the x. So I flip it over the y. So when I flip this over the y-axis, I hope y'all all see that it's the same thing. 1, 2, 3, 4, 5. So we got to draw that same thing. Use your straight edge. Oh, poo. I wasn't supposed to let go of it. So we have that and that looking the same. Okay. And the last one, negative is on the outside. Outside affects the y. If I'm changing the y, I'm flipping it over the x-axis. So this time, that means that this point down here is going to go up there, or this one. Okay. So instead, I'm going to go up 1, 2, 3, 4, 5, and that's going to be that starting point of my V. And now my V is going to go down instead of up. Okay. Are these two the same? They are the same, so we have an even function. Those two are not the same. Can't be even and odd. Okay. Last one like this. So f of x equals 1/2 x cubed. Again, parent function y equals x cubed. So we're looking something like this. It curves, okay, so you don't need to use a straight edge to draw this. Okay, that 1/2, I hope y'all remember that is again outside, so it affects the y. And this is similar to the one that we did in our on our assignment. We had a 1/3, I think, instead of a 1/2. So what you need to remember is it makes it squishes it top and bottom, so it makes it a little fatter. So it's a little fatter, but it comes back into the same place, but it needs to be on the outside for both of those. They still both go through that point 0, 0. Okay? Domain didn't change. Range didn't change. Okay? Negative x, as we've been done on all the other ones, we're going to flip it over the y-axis. So if we flip it over the y, it looks like this. Okay? Are those the same? No, they're not. This one, we're going to take our original one and flip it over the x-axis. So then it looks like this. Not the best one. Are these two the same? They are the same, so now we have an odd function. Okay, so you'll have four of them. They won't be in the same order, in the same place, so be careful, but I think you have a good grip on how to do those. Okay, this last one, again, I'll give you a graph that stops. Um, Give the domain and range an interval notation. So knowing that it stops, okay, your domain, you're trying to find the point farthest to the left, and that farthest to the left is -5. And farthest to the right is +5. Okay, to find the range, we look for the lowest point, and the lowest point is -3, and the highest point is +3. Okay, so there's the domain and range on my graph, and you can see how the points match up. Okay, the only other point that we have on the graph that's important to remember is this point right here. Okay, because it's a place where things change. But as you go and do these next four problems, you want to remember these key points. So watch how we do this. On this first one, we have f of x equals x plus 3. We've talked about this. That 3 affects the y. So I'm going to, and y'all, we did this that whole back page on the last lesson, so you can go ahead and figure out domain and range from here. If I add 3, it affects the y. My domain doesn't change. So I'm going to go plug, well, that's -5 to 5 because it's not going to change. And what am I going to do to each y value? I'm going to add 3 to it. So -3 plus 3, 3 plus 3. So you've got that part answered. Now, to go and add 3, take each of those key points and add 3 to them. So this is -5, +2, go up 3. 1, 2, 3. That's -3, 0. So -3, 0, go up 3 units. This is 0, 3. It's now going to become 0, 6. Um, this is the point 3, -3. So 3, -3 becomes 3, 0 because I went up 3 units. And then the last one is 5, -2. 1, 2, 3 becomes 5, 1. Okay? So from there, use your straight edge because all of these are straight. I think I hit the wrong button. Oh, there we go. Let's try that. Okay, so I'm going to go here. And you just connect them and it'll look like the original shape. All we did was take that original graph and shift every point up 3 units. Alright, let's go with 17, f of x minus 5. So this affects the x, which means my range doesn't change. So I'm going to plug in -3 to 3. And I'm going to do what to each x value? I'm going to add 5 to it because I don't want to do the opposite of what it looks like. So -5 plus 5 is 0, and 5 plus 5 is 10. So I'm going to take this whole graph and I'm going to shift it over 10 units. So -5, 2, -5, 2 is going over 5 units. Boom. -3, 0, -3, 0 goes over 5 units. I'm right here. 0, 3. So you go to 0, 3, move to the right 5 units. 3, -3. 3, -3, move to the right 5 units. And then 5, -2, move over 5 units. Okay, pull out your straight edge and connect them. So we have one part, 2, 3, 4. Okay, so f of x, y equals 2 times f of x. So we look at that. And that 2 affects the y because it's outside. And it's not adding or subtracting, so I'm not just shifting it up and down, I'm stretching it. So remember these points that we had. We started at -5, +2. Actually, let's go do this first. This affects the y, so the domain doesn't change. -5 to 5. Our range, I multiply every range value by 2. So if my lowest was -3, it's now going to be -6. If my highest was +3, it's now going to be +6. Okay, so I started at -5, 2. Multiply the y by 2. 2 times 2 is 4, so it's going to go up to 4. -3, 0. The y value is 0. That 0 times 2 is 0. 0, 3. The y value is 3. 3 times 2 is 6. Um, what's the next point? The next point we have is 3, -3. And -3 times 2 is -6. And then we have 5, -2. And -2 times 2 is -4. So there, again, you'll see as we graph it. So get your straight edge and graph that, and you will see that it looks like we've just taken that graph and stretched it vertically. Okay? All right, last one where we have to graph. 1/2 affects the x because it's inside the parentheses. So my domain is going to change, but my range is not. -3 to 3. Domain, we do the opposite. So multiplying by 1/2 is the same as dividing by 2. And the opposite or undoing that is going to be multiplying by 2. So I'm going to multiply my domain values by 2, which is going to give me -10 to 10. So when I normally started at -5, 2, this time my y stays the same, but my x got multiplied by 2. So it's now at -10, 2. I was at -3, 0. Multiply the x, which is -3 by 2. 0, 3 doesn't change because 0 times 2 is 0. 3, -3. The y stays the same, but I have to multiply 3 times 2, which puts me at 6, -3 now. And 5, -2. 5 times 2 is 10, so it came out to here. So, connect this one, and hopefully you can really see that this graph has been, it's like it was pulled on both sides. It was stretched horizontally. Okay, so that is the end of that. One last question that we have is for you to answer the question without looking at having a graph to do. And we've kind of been doing every problem like this, so hopefully this is not too difficult. The 4, you know, it affects the y, and the 5 affects the x. So I do the opposite with my domain. So instead of adding 5 to each one, I'm going to subtract 5. So -5 minus 5 is -10. And 5 minus 5 is 0. So it goes from -5 to 10. And each y value is multiplied by 4 because we do the same thing that we see. And it was -3. -3 times 4 is -12. +3 times 4 is +12. So we've gone over the study guide. If you have any questions, we don't have AO before the test, but I get to school early in the morning, and you are welcome to come see me. Send me an email. I'll be happy to answer any questions I can that way also. Thank you, and we'll talk soon.